So here we start with Chapter 12, Introduction to Organic Chemistry and specifically alkane. So basically we're going to first look at the nature of organic molecules, look at the functional groups. This is a table 12.2 that you're going to have to know, and you will know it by the end of that first set, which is organic chemistry. We're going to look at alkane, their isomer, drawing them, their shape, and I'm going to spend an extensive amount of time on how to name them. Then we'll probably just invite you to read their properties, a few highlights about the reactions, talking about cycloalkane, and of course drawing or naming them. So this is here where organic chemistry started. This is the study of living things. Well, today this is defined as the study of carbon compound. You need to know a carbon atom is tetravalent. Tetra means 4, means that it has 4 covalent bonds. Now this is here how things happen, and please review that side, understanding where you can have a more electronegative element and a more electropositive element. This is what defines a molecule as being polar as the polarity, and that's just some of the result of those covalent bonds and from the unequal sharing of the electron that takes place. Now they have specific three-dimensional shapes, and this is an example with ethylene, and you look at the shape it has. The 2 carbon atoms here are linked with 2 covalent bonds, which prevents the possible rotation. Acetylene, which has 3 covalent bonds, also prevents rotation of the molecule. Now we're looking at the different families, and those are to do with the structural features they have, where we classify them as functional group. And that table 12.1 looks a little bit scary, but just trust me, you'll know all of those. The first one here, when you only have single bonds, that's the name ending ANE, and the functional group name, family name, is called alkane. Alkene have double bond, alkyne triple bond, aromatic make circle, alkyl halide, we'll talk about this. And then you'll discover alcohol, ether, amine, aldehyde, ketone, carboxylic acid, anhydride, ester, amide, thiols, which have sulfur attached to them, disulfide, di means 2 sulfur atoms attached to each other. And I know you'll be overwhelmed, but just you'll remember those, and trust me, you'll know all of those by the end of that first section of the course. So we're going to first start with hydrocarbon, which contain only carbon atom and hydrogen. They only have single bonds. They have no functional group. Those are the alkane. Alkene have a double bond, alkyne triple bond, and the aromatic compound have a 6-membered ring. Now this is here a general rule for all hydrocarbon except methane, is that every single carbon must be bonded to at least one other carbon. This is what we call here the backbone of the compound, with hydrogen on the periphery. That's a general formula, CnH2n plus 2. N is the number of carbon atoms that exist. So if you have 2 for N, that will be C2. Then 2 times 2 is 4 hydrogen plus 2, that's 6 hydrogen. This is why we call them saturated. They have all hydrogen attached to each other. Then we're going to look at them where they have different shape, and we call those isomers. Now, compounds that have the same molecular formula but a different structural formula, we call those isomers. This is an example. You can either have a straight chain, and right here we have 4 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. They can either be in a straight chain, or they can have a branch chain. So you see right there, Carbon number 3 have a branch point. Looking at the structure, straight chain alkane has all its carbon connected in a row. Branch, of course, there's a branch, and then constitutional isomer will have the same molecular formula but different connection. This is here the first example of drawing the structure. This is what we call the condensed structure. Shorthand, just to look at the drawing structure where the carbon to carbon and carbon to hydrogen bond are understood better than shown. Right here, butane, but means 4, you have 4 carbon atoms, structural formula on the left, and then the condensed formula will be CH3, CH2, CH2, CH3. Now this one, the structural formula looks different because it's branch, and in that case, the condensed formula will show that branch taking place on the carbon number 2. The name will be 2-methylpropane. We're going to understand that better in a little bit. Sometimes not all the CH2 group that we call methylane are shown, and when you have a repeated amount of those, we can use parentheses, and the subscript will indicate how many times is going to be repeated. So that molecule CH3, CH2, 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 CH3, if you count how many times the CH2 exists in the molecule, 1, 2, 3, 4. So you can write this as CH3 parenthesis CH2 4 times CH3. And then we're going to go over what we call a line structure. You have to practice this. This is a shorthand way of drawing structures where every carbon and hydrogen atom are not shown. So it looks a little bit complex, but if you look at the molecule on the far left, the very tip that points down to the bottom corresponds to a carbon atom attached to 3 hydrogen, because remember, carbon atom can only form 4 covalent bonds. And then the other one will be just where you have 3 lines together. So remember, carbon atom has 4 covalent bonds. So you just show here those lines. You need to know that in the middle, visualize a carbon atom that is attached to 1, 2, and 3 carbon atoms. And then the last option, well, you have to fill it with a hydrogen atom. So how to draw those line structure? Well, as I say, it's a shorthand way of drawing structure in which you don't actually show the carbon or hydrogen atom. Those are the key rules. Each carbon-carbon bond is represented by a line. Anywhere a line ends or begins, as well as any vertex where 2 lines meet, represent a carbon atom. Any atom other than another carbon or a hydrogen attached to a carbon must be shown. And then remember that we have those 4 bonds for carbon atoms. So that means that all bonds that are not shown for any carbon are understood to the number of carbon-hydrogen bonds that would exist. This is an example that's from your textbook, 12.5. Just try to convert those condensed structure to line structure. So the first one, where you find the longest continuous chain of carbon atom in the condensed structure, and you start your line structure by drawing a zigzag line which how many number of vertices and line ends to the number of carbon atoms that are on the chain. Show the branches, and remember a carbon atom has 4 covalent bonds. For the first one here, the solution will be that you start the zigzag line. So I look at A, 1, 2, 3, 4, 5, 6 carbon atoms. So I draw those 1, 2, 3, 4, 5, 6. Then I look at where do I have branches. I see that on carbon number 3, 1, 2, 3, I have a CH3 going down. I put a line going down. I know the end of that line represents CH3. Then on carbon number 4, I have a CH3 going upward, so I'm going to draw a line going up. And I do know at the end that represents 1 carbon atom attached to 3 hydrogen atoms. Now when I look at here, B, well, that's going to be I have 1, 2, 3. On that second example, where this is the complete line structure, you're going to look at here how many carbon atoms you do have, and you're going to draw the zigzag line 1, 2, 3, 4, 5, 6 carbon atom as well, but this time on carbon number 2 you have a OH attached to it, you need to show it, and on carbon number 4 you have a chloride attached to it, you need to show it. Okay? So at any given instant, remember that most of the molecule will try to find a conformation where they are in the least crowded conformation, lowest energy, extended conformation, so they stay away from each other. And how to name the alkane? I'm going to spend a lot of time with this. This is here what we call nomenclature, and this is from the International Union of Pure and Applied Chemistry, IUPAC. I will ask you a question naming those compounds according to IUPAC, where there are actually 3 parts: a prefix, a parent, and a suffix. Now how does it work? The prefix is where are the substituents located. The parent is going to tell you how many carbon atoms are on the longest chain, and the suffix, which is the family that that molecule belongs to. So straight chain alkane are named by just counting number of carbon atoms and adding A and E if you find there's only 1 covalent bond between the carbon atom. You have to know that table. 1 carbon atom is going to start with met, 2 carbon atom et, 3 prop, 4 but, 5 pent, 6 ex, 7 ept, 8 oct, 9 non, and 10 dec. At the end, if you only have single covalent bond, that will end up with A and E. So 1 carbon will be methane, 2 carbon atom with a single bond attaching the carbon is ethane, 3 propane, butane, and so forth. Then we have to look at what we call the substituent. Example here, those are called alkyl groups. CH3 is methyl, CH2, CH3, ethyl. So basically you still go back to the first table I gave you, met, et, prop, but, but then you add YL at the end, so methyl, ethyl will tell you how many carbon atoms and the fact that they are substituents.